Sorry, I didn't realize I was mute. Okay, so spend a bit of time to look at these questions for today's tutorial. And also you may start to work on these questions. One will take about 5-10 minutes to see if you can work this out. These questions require a little bit of background from CETS that you have learned last semester, talking about partial pressure and converting these saturated pressures to partial pressures in terms of vapor. Then that's where you may want to work with the data you got here. Okay. Can we start? Okay, before we start for today's attendance, instead of using the cam to record it, because I believe the weeks before when we used the cams for attendance taking, quite a number of students couldn't get their attendance, recorded. So this week I'm going to use back the traditional way using the Google document. So you can find this actually in your the times there. I already put them inside time so that you can click and then just write down your attendance or your email address. Use Taylor's email, please. And your student name, ID, and also which modules are you, the 3 credit hours or 4 credit hours, and which program. Okay, so this is attendance for this week. And let's see if there's anyone needs to come in. No. Okay, so oops. Let's start for today's tutorial. Okay, so we talked about TLV at 25 degrees Celsius and 1 atmospheric pressure. So now we are given the saturated pressures for heptane and taurine, and also we are given the mole percentage in terms of Y here. So your X here, so this is your X value. And also you are given each of the TLV, TWA, this is basically TWA. Yeah, so let's start. So in order for us to convert, because this is what we know when we have X here is in liquid form, we want to know what is the enclosed. If let's say this is X, I, so we want to know what is the mole percentage in terms of vapor phase. So we can start with this P saturated for heptane. We have, okay, X1. Oops, sorry. Let me rephrase that. So let's go back to Raoult's law. Okay, Raoult's law says that you have your PI, your partial pressure, equals to Xi and X saturated I. Okay, so now we have our P saturated for heptane, HEP here. So it's given 46.4 mmHg, and also P saturated for taurine at 28.2 mmHg. Okay, I think someone's want to come in. Hold on a second. Okay, so now we have our partial pressures given for both components. So now we want to calculate what is our pressure, our partial pressure for heptane. We have X, our X is 0.5 times 46.4 give you 23.2 mmHg. And also we have pressure for taurine. We have 0.5, 28, oops, 28.2. So we get 14.1 mmHg. Okay, so in that case, we have total pressure equivalence to your P heptane plus P taurine. We have 23.2 plus 14.1. Total, we have 37.3 mmHg. So now we want to know what is our mole fractions in the vapor phase. Here is where we use Dalton's law. Mentions that your Yi equals to your Pi over P total. Okay, so in this case, your heptane, we have 23.2 over 37.3. We have 0.622. So Y taurine, we can either use 14.1 over 37.3, or we can sort of use 1 minus 0.622 because we know the remaining is that. So 0.378. Okay, so the question wants us to calculate what is the TLV mixture, okay? And we also know that TLV, TWA mixture is your total concentrations divided by your total CI over TWAI. Okay, so our concentrations here we know is 1. Okay, because this one plus this one we give you 1. The other one is 0.622 over TWA, which is given here, of heptane is 400 plus 0.378 divided by taurine is given as 20. So we have 48.9 ppm. Okay, so this is our TLV mixture, a total of 48.9 ppm. So that answer questions 1. Any questions so far? Yeah, for question 1. Okay, if no questions, then we look at question 2 here. Okay, question 2 is a straightforward question. Yeah, a processed plant inventory has this chemical. We have, let me highlight them, vinyl chloride, we have methyl ethyl ketone, and also we have ethylene oxide, we have styrene, and we have cyclohexane. So as an engineer, you are asked to look at what are these hazards of this chemical and what are the informations that you want to request to perform that appropriate assessment for this risk. So very simple. First question is, what are they first? Tip is go Google the SDS for this chemical. We used to call them MSDS in the past, okay, Material Safety Data Sheet. But MSDS is an old form of SDS. It consists of only like 9 sections. And then it was known that there are lots of information missing, and also it was not a standardized document. So anyone has any information, they would just put in. If they don't, they just remove. So sometimes you may get an MSDS of only 7 sections, etc. So then the governing body decided to say, okay, time for us to standardize all these chemicals safety data sheet. So the new one, we called it SDS. We removed the way M. And inside here, there are total of 16 sections. And every section is made compulsory to have data regarding to this chemical. So this will tell you all the information that you need about this chemical. So it takes about 5 minutes to go Google these 5 elements in here to see what are they. And then we can discuss. I'm just going to show you one example on vinyl chloride perhaps, and the rest you can do it on your own. But right now I want you all to just at least Google them and have a look at all these SDS. What are they? Okay, it takes 3 to 5 minutes. Okay, so now let's try one of the elements. Maybe we shall go for vinyl chloride. Let's see, where's my Safari? So all you have to do is type in vinyl chloride SDS, and then you will see a list of all the SDS given. Okay, let's see which one do we want to look at. Anything will do. Okay, we'll just take this. So Section 1 is about the chemical production company. So whichever company that produce this, they have to list down what are their chemicals, what are the address of the manufacturer, and the chemical formulas and all that must be listed in here. Okay. And sections 2 talk about the hazard identifications. Remember in chapter 1, we did talk about the NFPA. So this is where you will get the data here. Like you can see what is the health data, which is now number 2, which is actually is quite reactive. Fire and reactivity. So you can see that this chemical, vinyl chloride monomer, is very, how to say, it is easily flammable. Yeah, and it's considered high reactivity, and also it has some health hazards in here. Okay, what I want to bring to your attention is, what do we do with vinyl chloride? We use them every day, but we use them in a polymer form, which is our PVC. PVC stands for polyvinyl chloride. And before it was formed to become a polymer, the monomer itself is in liquid forms. Monomers are very unstable because of a loss of unbind chain within the chemicals itself. So they are reactive, they can easily vaporize, and then they actually give us health hazard. Okay, so you can see over here they even list out is danger, is poison, extremely flammable and vapor, and even the vapor itself may cause flash fire and may be fatal if inhaled. Okay, may cause frostbite. Okay, um, those are the things you can see. So these are the informations that we want to get from the SDS. So if your chemical storage, if let's say you work in a company that produce vinyl chloride monomer, so then you must know what are the potential hazards, like things like this that you need to know. And then you can take actions to, like, what sort of PPE do you need? What sort of storage environment that is required to store chemical like this? And also it's written here, avoid temperature above 400 degrees Celsius because it can easily auto ignite. And flammable gas that is heavier than air and blah, blah, blah. So everything, all the informations are in this 16th section. So this is section 2, and it does talk about like storage wise, ventilation, and first aid, potential health effects. It's all in here. Okay, sections 3 talks about the chemical compositions. What are they inside? Sections 4 talk about first aid measures. So in case people inhale it, remember in chapter 2, we talk about the 4 ways of toxicants to enter our body. So the information you can get from SDS is in section 4, like how it enter our body by inhalation, by skin contact, by that injections. In this case, not a likely route of exposure unless people take and drink it, which is very seldom, or to almost to be impossible. So in case you have any eye contact, what do you want to do with that? Okay. So this is where you get information about the toxicants. And sections 5 is where you want to prepare, because since we talk about that this chemical is highly flammable, you also need to prepare what are the extinguisher. How do you firefight it if, let's say, it causes fire? It's in section 5. Okay, so section 6 talk about release. If let's say we have accidental leaking or spillage, what do we do? Okay, and section 7 talk about generous handling and storage. What do you need to do? how do you want to store it. And sections 8 is what we are interested in for this chapter. You want to see what is the 8 hours TLV, TWA values. Just now, the first questions we talk about heptane and taurine. Taurine itself is already a very toxic chemical. And taurine for TWA is 20 ppm. Take a look at vinyl chloride. The TWA is only at 1 ppm, meaning just by inhalations, a little bit of the exposure of this chemical, it can actually be quite fatal. Okay, so the STEL is 5 ppm, is again written here, not exceeding any 15 minutes periods. Okay, so that is a level that we are looking for. So in case you're wondering, where can I get all these TLV, TWA values? It is in all the SDS. They must put it down. Okay, and then it talks about what are the PPE that is needed. So for some of you, or for most of you, you're going to do your FYP 1 and 2 in 1 or 2 semesters time. So, and you will notice that we will always ask you to prepare what we call a JHA, the job hazard analysis. And there's one section that you're asked to list out all the PPE that is required. So depending on what chemicals you use, and because we also asked you to give us all the SDS for the chemicals that you are going to use. So look at these sections, then you will know what are the PPEs required that is written in your JHA. Okay, because a lot of time, what happened is student will just download the SDS without looking at it, just submit it. And then they give us their own version of JHA, what sort of PPE equipments that they need without referring to this SDS. Okay, those are the time, if let's say you find that things are not tally, your JHA will just get rejected. And every time when it's rejected, you have to redo it and resubmit it, because you will only be allowed to start your FYP experiments after your your JHA has been approved. Okay, so you would know you know that if you're handling this, you need to do it under fume hood. Okay, sections 9 talk about the physical and chemical properties. So in case you want to know what are all these flammable limits and all that, it's all in here. Okay, we are going to talk more about flammability limit, octo-ignite temperatures, what are they, in chapter 6, which in 2 to 3 weeks from now. Okay, stability and reactivities in section 10. So it talks about like what happens when you get contact with air, oxygens, and etc. Okay. And again, this is the toxicology informations. This is basically talk about like what are the toxicity data, what is the lateral dose. Yeah. So, and ecology and disposal. If let's say you want dispose, all chemicals must be treated. So they have certain waste number. If you can see that EPA 40, CRF 262 hazardous waste number. So meaning if let's say you want to dispose this, there is a set of rules and regulations on what to do with this chemical referring to this number. Okay. So transport informations, regulatory information. So these are the main 16 sections that you can find in the SDS. Any questions so far? So this is only one chemicals. You are supposed to study for all 5. Then you come up with the list on what you want to do. If you are the chemists or the chemical engineers for this lab or this storage area, what is your plan on how do you want to store them? What is the plan on how do you want to utilize them? So like vinyl chloride, definitely if anyone wants to use it, it has to be in a fume hood. And also it will be good if respiratory PPEs are given to the staff. who wants to handle this chemical. Same with styrene here. Styrene is another monomer. Okay, these two are highly toxic. Okay, any questions so far? So you can continue to do it for the rest of the chemicals and then write your own reports on this one. But I'm not going to go into detail on that. So questions one that you want to ask, because I asked you, what are the additional informations that you want? One is your SDS. Second is how much chemicals to store, to use, and also if to use, at what temperature or pressure that they are being used. Okay, so I guess this basically cover chapter question 2. Any questions so far? Let me just check if everyone is here. Okay, cool. So in that case, let's move on to question 3. So question 3 is very similar to question 1. In fact, it's easier than question 1, but there's also extra step to ask you to see if this air contains of this 4 ppm of carbon tetrachloride and 25 ppm of 1,1-dichloroethane, if they exceed the value. So you have to calculate the mixture TLV. Then you want to calculate whether it has exceeded the values that you calculated or not. Take 1 to 2 minutes to get this done. It's a straightforward question. Good, someone got the answer. So to do this straightway, TLV, TWA mixture, you get something like total of concentrations over total of concentration over TLV, TWA, I. So in this case, you get 4 plus 25 over 4 over 5 ppm plus 25 over 100 ppm. Okay, just now someone already showed the answer, 27.62 ppm. So, but that doesn't answer the question because this is only the mixture of the TWA. So has the value exceeded? So means your total concentrations here is 4 plus 25, which give you 29, which is larger than 27.62. So the answer is yes. Your operators has been overexposed with this chemical. The concentration is higher than the TLV, TWA level. Yep, so straightforward, easy. Okay, any questions so far? If no, then let's move on. Okay, this is an interesting question. Just a brief background. Until now, we have no idea how our final exam or final assessment will be. So if we are having a final assessment like what we had for last semester, then the questions will be more open-ended. And also the questions will gear more towards finding your own data and tell me what do you want to do. Something similar to questions 2 like this. Okay, question 2. That I give you certain chemicals and you tell me what you want to do with this chemical. Okay, so in your own words. So you have to find MSDS, you have to find out this, you have to find out that, and then you tell me what is your plan. Those are open-ended, open source questions. However, if we have a 3-hour sit-down test in the exam hall, okay, this is normally my question 3, part B, which consists of 15 marks. Okay, so what I like to do is I'll give you a set of data like this. This is the environmental concentrations of certain chemicals, and I give you the timestamp. And so we have this and we measure, and then you tell me if your operators work in there for 8 hours. Are they being overexposed with this set of data given? So there's a lot of calculation. Okay, so your TLV, TWA is given. Yeah, your TWA is 150 ppm. Let me change the color. STL is at 160 and ceiling is at 250. Okay, so then you're given all this data and also you're given the informations of what time your people start and what time they end. So they start, these workers start at 8 a.m. and work until 5 p.m. Okay, lunch break from 12 to 1 p.m. So meaning between this time, there is no exposure. Okay, so you can start calculating it. I give you about 10 minutes to try out this. So to start you off, because you see the first timestamp is at 8:10 a.m. So since we don't have any data before that, so we will start at 8 a.m. assuming the concentration did not change. Okay. However, if you are given the data at 7:30, so what you would do here is you would interpolate the data and get at 8 a.m. what is the estimated data over there. Yeah, so you may want to fill up this table and see what do you get. I'll give you 10 minutes to do this because it requires some calculations, some calculator to do some interpolations because you may want to get a 12, this is not AM, PM data, and also a 1 PM data here. So you can do interpolation here. You get your X, you get your Y, and then another hint is your TWA data is also given. Let me see, where is my OneDrive? Oops, sorry. Okay, mention all the formulas again. So you can see your TWA is basically this formula. Okay, so in another words, total CITI over 8 hours, where T is in terms of hours. Okay, so you may start doing this. So now it's 4:40, 10 minutes. Start 4:40 p.m. Okay, takes about 10 minutes. 4:50, we'll start to discuss on these questions because I want to make sure that you really know how to do this. In case we have a sit down 3 hours SM, this is definitely question 3, part B, 15 marks. Okay, so are you ready? Let me erase those that's not needed here. Okay, so to do interpolation in case you have forgotten how to do it, so simple, like x minus 162 divided by 142 minus 162 equals to 12 minus 1120 over 12 minus 1120. So here you have 40 minutes over 52. Oops. Uh-oh. Hold on a second. Let's see. So we have 52 minutes here. Okay, so then you just do x equals, you get your value. So your value will be roughly around, let's see, 146.6 here. Okay, so in that case, your x here will be 146.6 and your y here you get something along the line of 153.1. Okay, so this is in terms of ppm. Okay, so in case you're wondering what is y, x and y. Okay, so the next column is where I normally like to calculate what is the time exposed in terms of minutes first. Okay, time in terms of minutes for exposure. So from here to here, the answer is 10 minutes. But from here to here is about 55 minutes. And then the next one is 62, 73, 40, 12, 48, 17, and 46, 70, 48, and 59. Okay, so this is the time in terms of exposure time. So then remember just now we say we need it to be in hours, so then you convert into times in terms of hours. Okay, so you have 0.167 hours, 0.917, 1.033, 1.217, 0.667, 0.20, 0.80, 17 minutes is 0.283, 0.767, 1.167, 0.8983. Okay, so the next thing is that you want to know the average concentration because this is in between here. So which data do you want to take? So what I'll normally do is I will open up another column called concentrations average in terms of average. So in ppm also. Okay, so what I will do is I'll take the average of these two. In this case will be 110. Then the second average that give you 55 minutes. The average is 120 and so forth. So 136.5, 152, 154.3. And also take notes here because 12 to 1 here. So meaning between here to here. Is it this one? Yep. This 12 minutes, this 48 minutes. Over here, there is no exposure. Okay. So this one. So because from here, 12 o'clock, this 12 minutes we still have the this 40 minutes we still have exposure, but this 12 minutes and this 48 minutes here to here, 12, 48 here, there's zero exposure. Okay, so that's where you have to take notes of. But from this 1 to 17, this 17 minutes, you have exposure. So you want to take the average between 153.1, let me highlight it, and 157, that give you the 17 minutes here. Okay, so in this case, you get something like 155. Then you continue. 2, 159, 141.5. Okay, so the last column here is your CI, TI. You want to times these two up. Okay, you get your data here. So you get all your data and you sum it up here. Okay, so you get something like 1178.189, or you can put it to 1178.2, doesn't matter. So your TLV calculations, TWA calculations for 8 hours is total of CI, TI over 8 hours, which is 1178.2 over 8. Roughly you get 147.3 ppm. Okay, so this is how you calculate the 8 hours of TWA exposure level. So let's take a look at these questions. You are given the TWA at 150 ppm, yeah, over here. And your level is at 147.3 ppm. Even though you are not considered overexposing your staff or your worker, but the values is too close. So a lot of time when we look at data like this, the next thing we want to do is we may want to start to take action. Okay, in this case, even though it is not overexposed yet, but it's really approaching that limit. So before we start to talk about the actions, we want to look at a few more things here. So now we look at STEL. It says that STEL at 160 ppm. So let me put in some value here. So we will look at concentrations here. Anything that is above 160 ppm, we have one here. And exposed for how long? We have exposed for 70 minutes, 1 hour, 1.16 hours. So which STEL did says that your exposure for STEL is maximum 15 minutes, then rest 1 hour, and then you can go back to work for 15 minutes, and you have to rest for another 1 hour, and maximum 1 day, maximum exposure is 1 hour. So meaning you can have 4 times of 15 minutes interval. Okay, So, but over here, if you look at this data, the operators or the worker are continuously being exposed for 70 minutes. So in this case, this is what we call a non-compliance here. So for STEL level, it is a non-compliant. When we say non-compliance, means if, let's say, DOSH or OSHA, if let's say, depending on which country you are in, come in and do an audit or a spot check, okay, and find out this data that you have a non-compliance here. What happened is immediately you will be given a ticket that you will have to stop operation until you reduce this level, until it is compliance here. Over here, this level is not acceptable until you do something, clean up the environments, and to show them the continuous data of 24 hours or even up to 72 hours that you do not have an overexpose, then you're allowed to continue with your operations. If not, then everyone will be asked to go home. Other than the engineers will have to think of a way to reduce the concentrations, the toxicant concentrations in the air. Okay, so this is at STEL level. Remember, we have 3 levels to look at. So now STEL level is not compliance. What about the ceiling level? Ceiling level means you cannot exceed this level at any given point of time. So you can look at these concentrations here, anything that is 250, or you can look at here. Okay, so but one look at things, there's none of this value above 200 ppm or 250 ppm. So at the ceiling level, we are still consider compliance. So now we talk about actions. What do you want to do during these periods of time? You may also notice that at certain point of time here, 162, okay, you actually have some exposure here as well. Okay, so this is where the level is high. So as an engineer, it is then become our job to find out what happened. Why is that so? So we want to find out what happened during these periods of time over here and over here. Is that because the operators are changing chemicals? Is that because that is where you start up the pump? Or is that because that is a time that the reactors is heating up the chemicals? So these are the points, the key points that we want to find out. During these periods of time, what happens in the production line that causes a spike? You can see when you start the day, it is at a quite low level, 110. But as the day progresses, it go up, and then during lunch hour, it come back down a little bit over here. And then it spikes again after lunch. And when at 5 p.m., when things are going to settle down, it go down back again. So meaning this shows us that this data, this particular set of data, tie in very closely with your production, like the activities in the production. So you may want to find out what do they do during these periods of time that might causes the spikes, and then how do you want to reduce it? So in the events, it's because of changing chemicals. So do you want to redesign the place for changing chemicals? Do you want to change that from manual changes becomes an automated changes? Or do you want to have an extra exhaust system that to be activated during chemical change time to reduce the exposure level? So it really depends. There's no fixed answer to say what is right, what is wrong, because some company, they have budgets to do all the automation thing, but some company, they might not have the budget to do that. So you have to also play along with the budget that is given and to see what you can do as an engineer to reduce the exposure. If you can't change the process, then perhaps you may want to look at what sort of PPE that you can prepare for your operators so that they are being protected. Like perhaps instead of giving them just a normal mask, you may want to give them a respiratory mask for, like, depends on what is this chemical. If this is an acid, you may want to give them acidic mask, the acid prevention mask. Or you want to, if this is a solvent, you want to give them a solvent mask, respiratory system that come with the solvent filter, so that your operators or your workers are protected during these periods of time. Okay? Any questions regarding this class? Or am I talking to myself? Do I mute myself? No, it's not mute. Okay, if there's no questions, means that's about it for our class today, because I think we only have 4 questions. Yeah, because I just want to show you how we do a more complicated questions like this. Yeah, in case it comes up, if we have a 3 hours exam, this definitely is question 3. Questions like this, not the exact same questions. Then you may want to analyze what happens, what is the possible things that what you will do, or what would you do as an process engineer. Okay, so next week, if you notice that this week lecture class is talks about relief system, meaning, and if you take a look at the tutorial classes, the tutorial questions, there are more discussions, meaning they don't have a fixed answer. In that case, I would like to see all of you in campus. For those who are in Malaysia or for those who are in town, we are going to have a face-to-face class next week. Yeah, because I've requested to change the classroom. Initially, they give me LT2 and LT19. I asked them to change to a X-based classroom so that we can do our class group discussions to get the answer, because everyone may come up with a different answer. So we are going to have a class next week. But if, let's say, you're outstation or you're not comfortable to come, or you feel like you prefer to study from home, I will still have the Zoom sessions. I will just turn it on like today. And then for those who are even outside the country, you will be able to join the sessions as well. It's just that all of you make sure you have an active mobile data or something so that you can conduct the discussions in campus. Unless all of you tell me that you don't want a face-to-face class, we can discuss that later. If no one wants to come, then we will convert it into a Zoom breakout sessions. We can do that as well. Yeah, if not, then I'll see you all next week. And also, today is already week 4. Week 5, we will talk about hazard identifications. Then week 6 is your test 1. Test 1 will be an online test. By end of this week or early next week, I will let you know what are the chapters that will be covered in test 1. Most likely it's only chapter 1, 2, 3, which consists of these 3 weeks, the first 3 weeks classes, talking about introduction, talking about OSHA incidence rate, FAR rate, fatality rate, talking a little bit about the toxicology, how it goes into the body, how it's being discharged from the body, and also talking about all this industrial hygiene. This is what we call industrial hygiene, talking about the exposures of toxic chemicals and how do you do simple calculations like this. It will be a 1-hour online test. And most of the time, what I will do is I will open up the test for 24 hours and you can start anytime. But make sure during your start time, you have a stable internet. Because once it starts, then it will have a countdown ticking. It will just stop 60 minutes later. So if let's say you get locked out or something, then means your trial has been taken. So in that case, don't worry, don't go panic, just WhatsApp me or email me, let me know. Then we see what we can do. Okay. So if not, then I'll see you all in campus next week. Any questions so far? Let me go back to the Zoom page. Okay. If no, then I'll see you all next week then. Can we solve tutorial 4? We will do it next week, and we will do it in campus. Okay, so in that case, I'll see you all next week, and all the best. Okay, bye-bye.